Okay, the title of this session, 21st Century Operations, Smart, Secure, Sustainable. And it's great to see so many of you have stayed throughout the day. I know it's been a pretty long day, but this session is definitely worth waiting for, because we're going to be hearing about drones and robots for critical infrastructure. We'll hear about closing the gap between threat intelligence and operational cybersecurity with topical reference to UNC 3886, which has been in the news recently, if you've been following that cybersecurity story in Singapore. And then we'll be finish off with a case study of automation and AI at an Asian oil refinery. So three presentations, and then we'll let you go to the drinks, which I'm sure you're waiting for as well. So let me introduce our first speaker, who's come all the way from Germany to be here with us today. We really appreciate him making the long trip from Europe. Matthias Gronstedt, he says his professed task is to make drones usable in a scalable and efficient way for industrial settings and open up the third dimension safely and securely to existing business processes and to aid innovative new ones as well. So Matthias Gronstedt is the MD, Managing Director at HHLA Sky. And his presentation, boost security, cut costs, streamline with drones and robots. Matthias, I know you've been waiting a long time, but here's your chance. Thank you.
So, okay. Yeah, good afternoon, ladies and gentlemen. Thank you very much. I would like to bring you back to reality after these nice presentations about AI and manufacturing, and I like to talk about some real things and how and why we need to use mobile robots like drones, driving robots, swimming robots. This is not really working. Slow. It's kind of slow. Or? Okay, so HHLA Sky is actually an abbreviation for HHLA Sky, which means Hamburg Harbor Logistics AG. We are the terminal operator in Hamburg Harbor, which is the third largest harbor in Europe. And this is where we are born. We are a deep tech company about embedded software and back-end software. And I will try to explain what kind of challenges we are facing today. This is back to reality. So we are having traditional methods like we are going around inspecting all kind of things. So this is with facility plant inspection, predictive maintenance is being done with climbers, and also, let's say, wind turbines. When you see the blades, you know somebody is going down with a rope with a little hammer, checking if everything is all right. That's maybe questionable if we will have enough people in the future who are doing these jobs. And this also with for facade inspections or inspection of photovoltaic power plants, and creating a digital twin is also still being done with a laser kind of LiDAR sensor, and security surveillance, infrastructure inspections, and all these kind of things are being done manually. And this is a problem of dangerous working conditions. So what it means, we are always working in dangerous situations. It's high, it's dirty, it's dangerous, it's let's say hazardous areas. And this causes higher labor cost, often a longer downtime. What does it mean, for example? When we think of a harbor, you know, these gantry cranes, these are also inspected with industrial climbers. They are climbing the gantry crane around 1.5 to 3 days with 3 or 5 people. So that means the downtime is about 3 days, and the barge cannot be operated. So now this can be changed with mobile robots. Let them fly. So with drones, for example, so plant facility inspections, they will be safe in the future. I cannot see that really good. Okay. Yeah. Now this, I cannot wear my glasses right now. So that means scaffolding, no shutdowns, real-time visual and terminal data from the air is much of help. Predictive maintenance is because of you have pre-scheduled routes, drones are flying. For example, here bridges can be inspected, and this is mainly on also construction progress tracking. So this is mainly because of in Europe we are running out of construction engineers. So there are not enough construction engineers coming from universities, and therefore our 5,000 whatever bridges is hard to be inspected with this low number of construction engineers. So that means they need tools to do more in the same time. So therefore we are using drones to fly to inspect actually these cracks and things like that in the bridges. And also volume analysis are being able to be done. Energy asset monitoring, it's about flying around these substations. It's about photovoltaic and let's say finding out these little kind of hotspots which are harming the performance of the energy of the photovoltaic. Digital twin creation is being done outside the factory with photogrammetry, so we are able to actually fly around these areas you want to have a digital twin with, and then you can actually measure the distances. So that means, for example, when you're looking at a construction site or a facade or whatever you want, an infrastructure, you just fly once, and then you can measure everything in the digital twin in your 3D model, which has been calculated afterwards. Surveillance, security, that is an easy thing to think about. Drones can fly around parameters to check if everything is okay, and also driving robots, they can actually look at the fences if there are some damages or some other things. So crowd and event management, this is also very important. It's like, let's say it's the police who wants to see not the people who are walking around, that's not their purpose. The idea is if something goes wrong and the crowd is getting hectic, so they need to, so are the emergency exits still open, or are they being blocked by somebody? So that is what needs to be detected, and this is for sure something which is easy from the air. Environmental monitoring, it's also something what we are doing in our harbor. We have a long river which is called Elbe. It's like 60 kilometers long from the harbor towards the North Sea. So what we are doing there is we are flying with a drone, these 60 kilometers up and down, checking if there are some oil spills, for example, if there is somebody smuggling and all these kind of things. So disaster monitoring is also one of the major things which can be done. And yeah, and in oil and gas and chemical plants, there's always, it's always dangerous, and it's easy to fly with a drone or drive around with a robot, or as these walking robots from Boston Dynamics, or for example, they can easily inspect the things. So what does that mean? This overall, when we are using these mobile robots, the cost goes down because, and it's really more efficient. So that means we have cost savings around 40 to 70%. I will give you an example. As I've been telling you, the gantry cranes in the harbor are being inspected by industrial climbers. We are flying around these gantry cranes with a drone in the net time of 3 hours. So that means we have around up to 90% cost savings in the whole process, which is a lot. And safety, for sure, it is always safer when we first fly with the drone to check these, let's say, complex infrastructures, complex situations, and then afterwards, when we detect something, then sending a technician to actually repair it instead of him climbing around, finding out if something is wrong. Speed, yes, it's absolutely faster, as I've been giving you an example. and also the data quality is much higher. So when we see that, let's say when we are inspecting these power transmission lines, right? These are being done with helicopters today. There are two people. One is flying the helicopter, and the second one is having paper in his and making notes about something, some issues, some things like that. And this paperwork will be handed over to somebody. So, and this is what is happening, unfortunately, today always in many, many kind of situations that we are making notes, handing it over to somebody. He can maybe not read it properly, and then we are typing in the data in something applications. So this can all be automated, and this is actually the idea of drones and mobile robots to be used. And the data quality is for sure much better, because with the high accuracy of the drone and with AI, you can actually really do the same photograph every time. And therefore, you can actually compare the history of the spot you have been looking at and what has been changed. So, as I said, we are from HALA, we are from Hamburg Harbor Logistics AG. We are born in the harbor, going outside now. So all these challenges, what you have been seeing, are actually, we are having in the harbor when we are building our AGV kind of runways and all this kind of stuff. So therefore, we have been starting developing these kind of use cases, solutions for, and yeah, I'm happy that we are having such a big laboratory actually, which is 74 square kilometer wide. So with these applications of drones, we are actually targeting the market of critical infrastructure. I've chosen the critical infrastructure definitions from US Department of Homeland Security because our German ones was a little bit fuzzy. So this is more like accurate, I think. And therefore, with drones, we are targeting the transportation, which is harbors, rail transport, water and wastewater management can be also inside that. Essential chemicals, oil and gas, nuclear power plants, healthcare services is very important, and also energy, electricity, and for sure, first responder, emergency services are all users of drones. So what does the portfolio look like, what we have developed over the last 6 years? So actually it's an integrated control center. It's an industry IoT software which controls all these kind of drones. So we have a first responder drone, which is less than 4 kilograms. We have the automated X11. That is our inspection drone. We are using for the gantry crane inspection with the Sony Alpha 7R camera below that. Then we have an autonomous mobile robot. This is for security, surveillance rounds around the camp or corporate fence. Then we have the cargo drone, the X25. It's like a drone who can carry up to 7 kilograms if you want to keep on the maximum takeoff mass of 25 kilo. For sure, it can also carry 10 kilograms. But when you look at, first of all, it seems a little bit low, kind of, 6 kilograms, is that really much? Start carrying around 6 kilograms for a while, and most of the ad hoc or emergency deliveries are below 3 kilograms. So this is what we have to, take into account. Therefore, it's quite okay. And then we have the X25, which is a VTOL, which is a fixed-wing drone. It is like 3 meters wide. It's heavily being used for transport. It can carry also 7 kilograms, or it's being used for disaster recovery or border surveillance. So this guy can fly 2 hours with one battery charge, meaning 200 kilometers, which is quite okay. And it's also being able, which is not really much seen today, but we can also have it with a fuel engine, and then the drone flies 800 kilometers, which means 8 hours in the air. And then we have an all-sky station, which is a base station where drones are being charged and can take off. So that means the automation workflow is fully being closed. So exactly. And then we have a UTM platform, people may ask, what is that about? So if you think about drone traffic will be increasing over the years, and different operators are flying different drones, how do you actually coordinate them in the public air space? And this is an unmanned traffic management, meaning this is a tower of the unmanned airspace comparable with the tower of manned airspace. So this is a software which does it actually everything automatically. It can activate, just give you an example, it can activate 50,000 flights per second. So, and it is open ICC, this is our integrated control center, who is actually not a tool to fly a drone, it is a process management tool. It makes sure that all these processes you have to run if you are being made safe and cyber secure. So with this control center, we can actually control more than 100 drones in parallel in the air, or we are able even to take our drones or other robots, AMRs. So will give you a quick example. Imagine we are having this AMR here. This one, the yellow one. This will be driving in your corporate environment on outside the factory hall, and the drone, the X-25, will fly into that campus, landing on the AMR, releasing a package, and then the AMR drives into the factory hall, delivering the packet where it's needed. So this is much more efficient than driving around and then you have to register at the office, at the gate, and all this kind of stuff, and you're also taking the risk out of your factory. So these are the logistics of the future, which can be done, which is, So 11 reasons to choose drones and mobile robot management or mobile robots. It's like simplified operations, payload range, capacity range, mission scheduling, flexibility, meaning you can actually with the software predefine your drone starts, meaning you have a scheduling of timing, dates, and things like that. When the drone is supposed to be starting, all full automatic, you just have to put the start button itself. Automated mission control, that means the drone is flying actually via the computer, via the industry IoT software. You don't have to do anything. I call these pilots sitting in front of the screen, I call them the coffee cup pilots, because they are just watching if some alarms are coming up or not. The rest is being managed or being done by the drone autonomously. Yeah, we are the only system in the world, which is still amazing and a little surprising myself. We are the only system in the world which is cybersecurity certified by TÜV according to IEC 62443, because actually we are flying a PLC, we are flying a notebook, and people can be damaged, the environment can be damaged, and all these kind of things. So it's actually necessary to have a cybersecurity in such an automated system, automation system, or in such environment. 3D terrain intelligence is also part. We can navigate and secure using detailed terrain mapping, because this data will be collected by the drone itself. Then we have geofencing. This is the capability which makes sure that the drone stays in a certain area, and if it tries to fly out because of wind or something is wrong, it will be shut down. Then we have several datas included, meaning there's a real situational dashboard, like what you see in the NASA, the big dashboard. So there's AIS data being included, which is the ships, where the ships are, all ADS-B, which is where planes are, where helicopters are. This is all being made available in a dashboard. Multi-site scalability and regulatory things. So that means this system is like an SAP. If you want to do things according to regulation, you have to have a software which does actually support it. So what we have been doing, we have included standard operating procedures from aviation. We have standard operating procedures from from industry and melted that into the software, which gives you the assurance you are doing everything correct. Because if a drone falls down and will maybe kill somebody, that's not a funny thing to be done. Yeah, and all of this together will give you industrial grade maturity, and with cybersecurity, the rules and regulations are being established into the software, and all industrial AI, fusion edge sensors, and automated multi-operational control. This is the game changer. So I would want to say, let autonomy do the heavy lifting things, because it's a safer operation, it's faster decision, it's a smarter asset performance and better margins, and efficiency is not just a tech goal, is our next margin driver. Thank you so much. So now we can do a Mentimeter. If you are wishing, just go on click on the QR code maybe. Not sure, I hope it's working. First time I tried it inside a PowerPoint presentation. Yeah, now you should see the question. Just type in what you think, what matters the most for you by using drones. Okay. Yeah, that seems to be it, or still somebody. So yeah, that's very interesting. It's actually very nice. Worker safety is of utmost importance, and this is actually where drones really and mobile robots really come into play, to make sure that we are not risking our colleagues' lives by inspecting high things, dangerous things. Then the rapid inspection, for sure, it's efficiency. So what you should keep in mind, using mobile robots, it's about efficiency, it's about quality, and it's about safety, both all three things being increased. So thank you very much. If you want to write me an email, if you have questions, just scan this QR code, and thank you very much.
Please stay. Thank you, Matthias. Yeah, so we do have time for questions for Matthias about drones and application of drones for critical infrastructure. Do we have any questions? I can think of a few. So I would imagine with drone deployment, we often hear about restrictions and regulations where you can deploy them. Is that an issue for you and your clients? The regulations in different
yes, it
industries
is.
And
it
countries?
it is a kind of an issue, but it can be overcome. It just takes a while. So we are actually consulting our customers in how to use the drones and how to overcome these regulatory things, because we have to think about one thing. I mean, there's a 25-kilogram robot flying in the air, and you don't see that anymore. So only you can see it on the screen from the control center, and that's it. So it is clearly understandable that the regulatory will, let's say, have a look at the air risk. How big is the air risk, and also the ground risk? Am I flying over crowded people and things like that? So yes, it is doable, but it's not easy.
Right. Okay. Mm-hmm. Okay. And you talked about cybersecurity. What is the intersection of drones and cybersecurity? Where does cybersecurity come into drones?
Yeah, I mean, let's say, so we are working with 4G or 5G connections between the drone and the control center. So you have the embedded software, you have the modem on the drone, then it goes into the mobile network, then it goes into the cloud, then it goes back to your screen. So it's the potential is there that somebody, let's say, if it comes to scale, in industrial use, for example, medical transportation of blood samples between the hospital and the laboratory. So if somebody is corrupting your flight missions, somebody is taking over your drones, fly it into something what you don't want to. Therefore, we thought from the day one, the cybersecurity is of utmost importance. And as you probably know, implementing cybersecurity afterwards, it's actually basically not possible. You have to do it by design. And this is how we started when we built the architecture of our software in 2019.
And I think you said you're the only certified drones.
I mean, usually in the drone arena, the control center is called ground control station because this comes from the remote control. You know, every drone is controlled with a remote controller. We disabled that because of the failure, kind of human failures. So yeah, and unsurprisingly, nobody in the drone world has taken care about that yet. I don't know why. But it is what it is, yeah.
All right, okay. There's no, oh yeah, sorry, what?
You mentioned about the seamless.
Sorry.
Mm-hmm.
You mentioned about the seamless data for autonomous. How do you manage that? Because that's very unique.
So seamless data according to the workflows and things like that. Okay, so I give you an example. It is when the drone, for example, flies around a container bridge or gantry crane in the harbor. So there are 57 neuralgic points which has to be reported to the government twice a year or 3 times a year. So we are actually taking photos of 57 points, and we are taking pictures around 800 to 1,000 pictures. So before these, our maintenance engineers were sitting there looking up picture by picture and checking is everything still okay. So therefore, we have built an AI, meaning the drone is landing, then the data will be transferred into our integrated control center. In the back end, goes into an S3 bucket. From the S3 bucket, it goes into our self-developed AI, and then the pictures are being processed, and they can detect welds, joints, screws, and all this kind of stuff. And then it will be checking: is this suspicious? Is it wrong? Or is it damaged? Or is it okay? And therefore, our maintenance engineers just have to look up, let's say, 50 to 80 or 100 pictures instead of 1,000. And then this can be connected to the terminal operating system, and or seamless data, let's say, is also, we have done an integration with ServiceNow for a huge kind of consulting company, which is named Accenture. So this is how the workflows actually will be future proven, I would say, and much more seamless, and the data will be automatically transferred and being put into the following softwares.
Okay. Oh yeah, sorry, short question.
Okay, I just want to ask about the BV loss. Is there any governing policy or any standard guideline on the BV loss?
I would not say so, because it's in Europe, it's a case by case. So actually, we have a customer who has founded a drone delivery airline, delivering the blood samples between a hospital and the laboratory. These distances are 10 to 50, whatever, kilometers, and every route needs to be approved by the Civil Aviation Authority. This is actually also, I would say, a nice process, because then you are, as a drone operator, you are sure, yes, it's been approved, it's okay, and I can fly this route every day 5 to 6 times. So it's actually something which needs to be proven because of the air risk and the ground risk you are flying over, and even the software and on the drone and the safety mechanisms on the drone, and even the software in the back end needs to be approved by the local civil aviation authorities. So yes, everything is possible and can be done, but it needs to be approved.
But there is no single policy yet.
No, because all environments are different. No, let's say if you fly over Hamburg, Hamburg is completely controlled airspace because I have next to my harbor, I have the Airbus airport. Then I have the airport of the international airport right in the city. So that means in a radius of 9 kilometers, everything is controlled airspace. So basically, no drone will ever fly. So, and then you have, this is why all environments are different. Paris is different to Hamburg, Munich is different. So this is why you need an approval for the time being, let's say, for each single mission you want to fly. But this approval is for 1 year, at least.
All right. Thank you for the question. Thank you. With that, let's show our appreciation to Matthias from HHLA Sky. Thank you very much.